Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. Whether you're targeting a grade 7 or pushing for a 9, let's get into it.
Hook! This one algebra slip lost more marks than any other on last year's papers. A tiny sign or a forgotten half, and suddenly a 4-mark question becomes 0. Sound familiar? Today, I promise a trick that makes completing the square a reliable way to bank marks every time.
I've lost marks to that exact thing. Tell me the trick. I need something I can remember under exam stress.
Right, the concept. We'll work through one clear method that works whether the quadratic starts as x squared or 3x squared. First, the aim. Turn ax squared plus bx plus c into a form a times x plus p squared plus q, or when a is 1, simply x plus p squared plus q. Why do we care? Because that form immediately gives the parabola's turning point, the coordinates minus p, q, and makes solving and sketching straightforward. Step 1. If a isn't 1, factor a from the x squared and x terms. Example, 2x squared plus 8x plus 6 becomes 2 times x squared plus 4x plus 6. Step 2. Take the coefficient of x inside the bracket, here 4, halve it to get 2, then square that to get 4. Add and subtract that square inside the bracket so you don't change the expression. 2 times x squared plus 4x plus 4 minus 4 plus 6.
Step 3. Group the perfect square and simplify the constants. The perfect square is x squared plus 4x plus 4 equals x plus 2 squared. So we get 2 times x plus 2 squared minus 4 plus 6. Expand the multiplier across the constants. 2 times x plus 2 squared minus 8 plus 6, which simplifies to 2 times x plus 2 squared minus 2. That's vertex form. The vertex is at minus 2 minus 2.
I like seeing the numbers move, but why do we halve and square? I always forget whether to halve before or after factoring.
Good question. You halve the coefficient of x inside the bracket, so if you factored a out, use the number that's left inside. Algebraically, halving the b term comes from reversing the expansion of x plus p squared equals x squared plus 2px plus p squared. That 2 is where the halving comes from. If you forget to divide by 2, your p is twice as big and your constants blow up. That's the single most common exam error.
Let's contrast with a simple a equals 1 example, so it's crystal clear. For x squared plus 6x plus 5, halve 6 to get 3, square to get 9, then write x squared plus 6x plus 9 minus 9 plus 5. That gives x plus 3 all squared minus 4. Vertex at minus 3 minus 4. Same steps, fewer numbers, because a is 1.
Exam technique note. When you write answers in an exam, the examiner is looking for method as well as accuracy. For a standard 3-mark question, you might see marks split M1, M1, A1. M1 for setting up a correct form, M1 for carrying out the square completion correctly, and A1 for the final simplified answer. Even if you can't finish, write your setup. That's an M1 mark waiting for you.
Here's how to make marks visible. Write each step on its own line. Factor first, show the add and subtract inside the bracket, extract the perfect square, then simplify constants. Don't hide steps on the same line. Examiners love clarity. If there's a show that question, copy a line that matches the required form exactly. Don't jump steps.
What about common rubric traps, like when they give you show that? Do examiners punish algebraic rearrangement if you took a different route? If the route is mathematically valid and each step is justified, examiners will award marks.
But with show that questions, they often expect you to reach the exact form they display, so aim to mirror the target expression. It reduces ambiguity. And if a mark scheme gives a method mark, show the key algebraic step explicitly. That step wins the M1, even if your arithmetic is messy.
Quick win. Half the b, square it, add and subtract, and if a doesn't equal 1, factor a first. Repeat that sentence in your head before you write anything down. Practice it until it becomes automatic. Now a short worked example, narrated so you can copy it into your exercise book.
Worked example. Complete the square for 2x squared plus 8x plus 6. Step 1. Factor 2 from the x terms. 2 lots of x squared plus 4x plus 6. Step 2. Half 4 to get 2. Square to get 4. Add and subtract inside. 2 lots of x squared plus 4x plus 4 minus 4 plus 6. Step 3. Rewrite the perfect square. 2 lots of x plus 2 all squared minus 4 plus 6. Step 4. Expand constants. 2 lots of x plus 2 all squared minus 8 plus 6. So 2 lots of x plus 2 all squared minus 2. Vertex at minus 2 minus 2.
Now do the 10-second substitution check. Always substitute a simple x value back into both forms. Take x equals 0. Original, 2 times 0 squared plus 8 times 0 plus 6 gives 6. Vertex form, 2 times 0 plus 2 squared minus 2 gives 2 times 4 minus 2 equals 6. Match confirmed. Do that quick check in the exam and it catches sign errors or forgotten factors almost every time. Don't skip the check.
I can see that catching mistakes. Any mnemonic for the halving rule?
Yes, my compact rule. Half the b, square the half, keep the balance. Say it once before you start. Half the b, find p. Square the half, that's p squared. Keep the balance. Add and subtract so the algebra remains equal. That 3-part line is a 5-second mental checklist you can use under pressure.
Practice prompt. Try this in 3 minutes. Complete the square for 3x squared minus 12x plus 7. Find the vertex coordinates and state whether the parabola opens up or down. Want an extension for teachers or parents? Ask learners to use the vertex to find the maximum or minimum value, or to set equal to 0 and solve for x where appropriate. That's a neat bridge to optimization problems.
Great. I'll try the 3x squared one now and then use the substitution check.
That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more worked solutions and revision resources at jcacademyonline.co.uk. Until next time, trust the process and nail that exam. Stay curious.